Welcome to Textile Update, the podcast where we can share our passion for textiles, fibers, and yarns. This is Gwendolyn Hustvedt.
This is the third and final podcast episode where I focus on the dye process. In this particular episode, I'm going to be talking about the stages in which we do dyeing. I'm also going to tack on a discussion of something called resist printing. Now you might think, oh, resist printing, shouldn't you resist putting that in dyeing and put it in printing instead? But in fact, resist printing is a dye method. So I'm going to talk about it here. And partly because it helps to think about this idea that we would dye things at a certain point in time. All right, so in the stages of dyeing, which is not related to the stages of grief at all, we have the choice of dyeing at different stages in manufacturing. So we can dye a fiber, we can dye a yarn, we can dye fabric. Of course, we could even dye polymers before they're extruded. Right? So we have to start there. We've talked about this already way back in an episode where we learned about fiber manufacturing, chemical spinning, and we learned how we could add a colorant to the solution, to the dope during the extrusion process, along with other chemicals such as finishes. But we want to focus here on colorants. Because this process of sprinkling a colorant into the liquid, whether it's, hot or, in solution in some way, polyester, nylon, olefin, right? Because we're doing this while it's liquid, and then it's going to harden in some way, coagulate, cool down, whatever. We don't have to worry about it doing chemistry. And I've already mentioned in a previous episode that synthetic fibers are notoriously more difficult to dye. So we're going to choose this solution dye process anytime we really want to have very good color fastness for the product. And we know that the color that we're choosing to dye it is a color we're not going to be sorry about later. Right? So we haven't picked some sort of weirdly random shade of chartreuse. We've picked the shade of green that most people agree grass is, so that we can use all of the chips that we were sending off to people to manufacture things like artificial grass. This adding of colorants means that we can add pigments, right? Because they don't need to form a bond with the fiber in any way. And so it can also sometimes be called mass pigmentation because we're pigmenting the plastic basically before we extrude it. We're going to, again, do this for these fibers that have pretty low dye affinity, and this really gives us a choice. It's also really great for outdoor applications where we might be worried that if we were using dyes, that the product getting wet might end up breaking the bond between the dye and the fiber. Some dyes are kind of fickle that way. But in this case, with mass pigmentation, we've solution dyed, another name for it, we've solution dyed the fibers, and that pigment is never going anywhere, right? Think about it. Right? You have a toothbrush, the bristles on the toothbrush are white and blue, and unless they're the fancy kind of blue bristles that are designed to change color as you use them, they're never going to change color. The toothbrush handle doesn't stop being purple, right? Because the pigments that made it purple are trapped inside that plastic material. And as I mentioned, we use pretty basic colors. You'll notice that in outdoor furniture, we kind of have trends. So they'll forecast a color as being popular. They'll go ahead and solution dye a whole bunch of the polymers, acrylic or whatever, to be the fashion color. So like a geranium shade and a teal shade may be forecast for as being popular for outdoor seating, and they'll manufacture a whole bunch. And then they know that in a couple of years, they'll need to start doing a different color. Maybe mustard will become the hot color, and they need to, or paprika, and they need to adjust the color that they're selling. So there's no nuance. These fibers are very flat, the shade that they are. Colors like black and white are eternally popular. Yeah, like those white plastic chairs you can buy. So we can manufacture the white fibers that can be used to make the cushions and the woven parts that would match all of that outdoor furniture. Easy enough. So that's stage one, before the fiber is even born. Stage 2 would be to dye the fibers. This is something I do if I'm getting ready to do a felt painting. So I have wool, bales of wool in the studio there at the Texas State University where I work. Students come in and do projects with me as part of an undergraduate or graduate research project. And one of the things that we might do is we might dye those wool fibers to be a particular color that we're looking for using a low impact acid dye. This gets very good dye penetration, and we can use just the fibers. So we could, if a student wanted to do a project where they were spinning the fibers that we dyed, they could, for example, make a tweed yarn, right? Because the tweed involves adding flecks of color into the yarn. Or in the case of the felting, they can use the different shades of dyed wool to create a picture of some sort or a design in the felting. The dye penetration is very good, so when you fiber dye, you want to expect you need to pay for plenty of dye because each of the fibers, all of the surface of the fiber is exposed to the dye liquor and can suck up plenty of dye. As soon as you twist the fibers into a yarn, the inside of the yarn is always going to have to fight to get enough dye, right? And so you're going to have to make sure that the dye really soaks into the inside. And if it doesn't, we call that ring dyed because the outside is a ring of color and the inside of the yarn is blank. So it's more expensive because we use more dye. It's also more expensive because cleanup is a bit more difficult. All of those loose fibers get into the equipment. Now, in the studio, it's just a big stock pot that we can wipe out. But if we're using a big fancy dye equipment, there can be small pipes and nozzles and things. And all of those have to be scrubbed carefully to remove any loose fiber. So for both of those reasons, fiber dyeing is the most expensive way to dye. We can move on and dye after something has been spun into a yarn. This is very common. Again, we want to know that we're dyeing all of that yarn a color that's going to be in demand. So we're not necessarily going to go for the hottest, the latest random color that designer asked for. For that, we will wait and just dye the fabric after it's been made. But we have to yarn dye if we're going to be doing jacquard weaving, or making anything like a plaid or a gingham or a two-color damask, right? We have to yarn dye to get the different colored yarns that we need. Yarn dyeing can also be called package dyeing, and that's because the cones of yarn, we use sort of it's not completely cone shaped. When we actually package dye, it's much more straight, and we wind the yarn onto the cone after it's spun. So it was on a different type of cone when it was spun, and then we unwind it and wind it onto the cones that are used just for package dyeing. And then after we're done and it's dry, we rewind it onto the cones that we'll use for storage. The storage cones are very pointy and stack on top of each other nicely. But the cones for package dyeing are designed so that they have perforations on the inside and that they hook together. So the top of the cone and the bottom of the cone are the same size. That means that we can stack the cones one on top of each other and they fit very closely. We put that whole stack onto a perforated spindle, a long pole that has little holes in it. And then we can pump the dye up the inside of the spindle and it will shoot out the little holes and into the inside of the cone where it shoots against the perforations or holes in the cone. And this helps us ensure that the inside of the package that's why we call it package dyeing. The inside of the cone of yarn is dyed as evenly as the outside. The dye then continues up the spindle, and when it gets to the top, it shoots down like a percolator coffee pot, like a fountain, and sprays down over the outside of the package. You know, when I was in grad school working on my master's, a doctoral student at University of Nebraska where I was, he was doing his dissertation on the computer modeling of this package dyeing process. So if you adjust the viscosity of the dye liquor and you adjust the pressure of the spray, right, and you wound the cone a certain tightness, how much dye would penetrate the inside of the cone. It's mathematical modeling. This is very much an engineering kind of thing. The cones on the spindles are in huge rings with 2 or 3 layers of spindles, kind of like the let's see, I'm trying to think what it would be like. There's a spindle at each point of the clock, all the way around the outside, and then a second smaller set of spindles, and then finally an inner set of spindles. And that whole huge collection of stacks of packaged yarn can be lifted using big hoists on the ceiling and dropped down into enormous pressure cooker vessels. And there, the cleanup is a bit easier because we just had way less loose fiber. The next stage of dyeing would be what's called fabric dyeing or piece dyeing. And the fabric dyeing is where we take large pieces of fabric that can be called piece goods. That's what they're actually called. And we will dye those in, well, I'm going to describe a jet dye machine. You could Google a jet dye machine and take a look at it if you wanted. The jet dye machine is basically a really, really long, big round pipe that is bent back on itself. So it could go all the way to the back of the room, 30 or 40 feet, and then the pipe turns up and comes back towards the front. So they kind of look like really long dragons laying there, right? You open the front of the machine and you feed the fabric in. You do this by starting the jet. The jet of water comes up out of a pipe at the base of the bottom pipe in the jet dye machine, and the water is pushed out at such pressure that it carries the fabric along. So you just unroll it off of the cloth beam and the fabric travels down the length of the pipe. It's fed into the pipe using the water that pulls it along. Then when it gets to the end of the pipe, you have to goose the pressure a bit to cause the water at the end of the pipe to shoot upwards and carry the fabric with it. It shoots upward and then realizes like, oh, the pipe comes back this way, and then the water starts traveling back down the pipe towards you, right? So it hits the back and then comes back towards the front. And just as the water is arriving at the front and carrying the fabric with it, you turn it off, grab that fabric, cut the fabric off of the cloth, and then stitch the fabric together. So you now have a huge loop of fabric, right? Maybe 60 yards long that is trapped in this enormous looped pipe. And then you shut the door. And you punch the buttons that tell exactly which of the dye chemicals to dispense when, right, to create the exact color you're looking for. And you push start, and then the jet pumps the dye liquor around and the fabric moves with it, and the whole thing travels around at this high rate of speed, and you know for sure that you're getting lots of penetration. This piece dye method allows you the fast response to color trends, right? Because you can say, oh, we're going to make these, all of these dresses for this designer, and they want this very particular shade of pink that only they're ordering, but we can dye enough fabric for them that then it can be shipped from us to the factory where the garment's being sewed together, and it's the color they want. All kinds of back and forth between the dye house and the designers to make sure that you're getting the right color. It's a story for another class, another whole topic, another day. The ways in which designers mess with people at the dye houses, the whole just kidding about the colors. We can see some problems if the fabric is too tightly woven or too thick. We might have a little bit of issue with penetration of the dye. But otherwise, you really can't tell the difference between a yarn-dyed fabric and a piece-dyed fabric. If you pull the yarns out of a yarn-dyed fabric, they're the color and you're like, well, did we dye this as yarn and then weave it, or did we weave it in the undyed sort of off-white color and then dye it? It's hard to say. I'm going to talk about a couple of special cases that we might see. If you had a fiber blend, for example, cotton and polyester, you have to make sure that you're using the right dyes, because the cotton is attracted to certain dyes and the polyester is attracted to other dyes. So you'll have to include both of the dyes that each of the fiber is attracted to. And that gives you a choice. You can either work really hard to make sure that the two dyes are the same color, that the human eye interprets them as the same color. We call this union dyeing because you're going for one color. Union, right? Out of many voices, one voice, right? That's what a union does. And union dyeing would be that the colors are in union, are in unity. So if you have a polycotton sheets and they're dyed a mauve color, then we found a mauve chromophore, a dye that would bond with the polyester. We found the same color mauve of a different chemical that would dye with the cotton, and then we union dyed it. But if you want to have an effect like a Tweety effect or a Heather effect, or if you wanted to actually do something kind of cool, let's say that you had a polyester warp and rayon filling or acetate filling, right? And the polyester is attracted to the dispersed dye, and the acetate is attracted to a different dye. Then we could actually say, let's put in the black that's attracted to the warp and the blue that's attracted to the filling, and it will look like we yarn dyed it, even though we didn't. So we could have one whole roll of cloth be black with blue filling yarns and give it sort of this, black gray effect. And then we could have the next one, we could have purple filling yarns, and then it would be kind of a purple gray effect. That's called cross dyeing. So the two dyes are at cross purposes. They're not in union, they're at cross purposes because we actually wanted two different colors. Can you tell the difference between that and yarn dyeing? No, you can't. Well, you could have a good guess if you see several pieces of fabric that have this effect going on, and you discover that the warp and filling yarns are two very different fiber types. Last but not least, we could dye at the product stage. This is called garment dyeing. This is done for quick color response and very often done with small items that are considered basics. So hose, tights, towels, underwear, that sort of thing. It allows you to pre-shrink and add the color at the same time. You'll especially do it for products where you don't need to have a tag, all right? So things like a t-shirt or underwear where they're saying labelless for your comfort, will also partly labelless for their ease because the printed label won't change color when it's dyed, whereas if you had a cloth label that was attached, the cloth label might change color after it's dyed and give it sort of a weird, matching color shade thing. So solution dyeing gives you the best color penetration. Product dyeing, least penetration. You have to worry about, maybe under the belt loop being undyed or at the bottom of the zipper being undyed. Fiber dyeing is the most expensive, and fabric dyeing is the least expensive. So that's what I promised about the stages of dyeing. And you have the choice at home for all of that, even mass pigmentation, if you were doing something with an epoxy and you added pigments to the epoxy. But I wanted to talk about resist printing. It's again called printing because it creates a design, a figured design on the surface. But this is where we actually take advantage of the idea that some things like wax or starches can prevent the absorption of dye. So what if you applied the wax or the starch in a kind of design and then dipped the fabric into the dye pot? Well, like tie dyeing, right? Resist dyeing with tie dyeing hinders the penetration of the dye, not using starch or wax, but using some sort of physical pressure, right? So in Japanese shibori, we might take blocks of wood and clamp them to the fabric. The fabric underneath the block of wood is pressed so tightly together that very little dye can be absorbed, maybe just the tiniest bit around the edge, so that whatever was under that clamp, you could do something with a binder clip, for example, and then you'd have this line where the fabric was pressed so tightly together that it remains undyed. The first type of resist printing is called batik. This uses hot wax resist and then cold dyes that don't need heat, right? So obviously the invention of synthetic dyes allowed batik to really take off. Because we now have these dyes that don't need any heat to be successful. But indigo, for example, is a dye that didn't need heat, right? It's just, in the olden days would have just been fermented. So we apply the wax and we go from light to dark. So if I'm doing resist printing of something, I might start with a large white piece of silk, and then I will apply, I'm using a batik-like process, but I won't use wax. I'll use rice paste, which is basically a starch, and I'll apply it in the design. So if I was using wax or rice paste, whichever, I'll apply it in the design. And then as I apply dye to the surface, right, I might be dropping the dye on with a brush or with a dropper. Batik artists will actually take the entire piece of fabric and dip it into the dye pot and then pull it out. And so let's say that I dipped it into, or I applied a very light shade of yellow. I could then apply more starch over the area that had been dyed or more wax. Maybe I did it in an indigo pot and pulled it out quickly, and it was just a very light shade of blue. The next layer of wax that I applied would trap the blue, the light blue. And if I dipped it back in the indigo again, I would get a darker blue, and then I could resist that, and then dip it again, and I would get a blue that was almost so dark it seemed black. So now I have a fabric with a design. Maybe it was dots and hearts that were in 3 different shades of blue. The very darkest blue is the background, the medium blue, the light blue, and then of course the white that I put down originally. With batik, you'll see this characteristic crackle or veining, which indicates that the wax cracked a little bit. Typically it happens during the last stage because it's losing its flexibility, although there's special wax you can get for batik work that has a lot of flexibility. I mentioned tie-dyeing. In India, tie-dyeing is called bandani. This is where we get our word bandana from. And with bandani, they will use a waxed string or yarn to twist, and so it often features dots and circular designs because they'll poke up a little tiny bit of fabric using a little prong, and then they'll wrap the waxed yarn around it and then move the fabric over and put the next on the prong and wrap it around it, and so you end up with these little rings or dots. And actually, if you were a textile collector, you might keep the bandani with it unwound, right, having all of the ties in place. So that's why it's called tie-dye, because originally we would have used wax string, not rubber bands like you do in hippie class now. That tying with the wax string is also used in the process called ikat. Now, ikat is different than bandani because ikat is a process that uses just the tying of the warp and filling yarns. So we're not resisting the fabric, we're actually resisting the yarns before we weave them, and then we will dye them, and then we will string them onto the loom and weave them at that point. It gives us a characteristic kind of hazy effect because while the resist was nicely sharply defined, when we put it in the loom, the yarns shift ever so slightly, and so the edges of the colored area change shape just a little bit. So I want you to go, please, and look for pictures of batik and bandani and shibori, which is the Japanese name for tie-dye. Bandani is the Indian name. And then also ikat, which is common in Central America. Batik is very well known in Indonesia. And I have some batiks that came from Indonesia. Gorgeous textiles. You could not believe that an artist had handmade those. So that is the end of dyeing.